Yeah, hi. So in the last session, we discussed about flowcharts. Now, in this session, we will talk about C4 model. Okay. So C4 model is a architectural documentation standard for software systems that break a software system down into four levels. Okay. So generally, a C4 diagram is composed of four main elements, each representing a different level of abstraction. So these elements are context diagram, container diagram, and component diagram and code diagram. Okay. So let me talk about context level. So this is the level one. So and it is a top level view of system. It illustrates how the system fits into the large ecosystem. It shows the system as a single box surrounded by its users and the system it interacts with. Okay, and this diagram provides high level overview of the system and sets the stage for the more detailed diagram that flow. Okay, so the same way we have level 2 container. So container diagram go one level deeper to describe high level interaction between the application or the services that makes up your system, and even a container can represent APIs, databases, file systems, and microservices, etc. So in any architecture, so this is more important, like having a context level diagrams and container level diagrams and component. So a component is a third level. So in this diagram, what we'll do is uh, we'll look at different code boundaries within a container. So this diagram help visualize abstraction of your code base. Okay, and the fourth level, this is the last level. So here you'll see code diagrams. Look at your architectural element map to code like classes, interfaces, objects, and functions. So as a bare minimum, most teams should create and maintain context and container diagrams for their software system. So component diagrams are can be created if they add value, but you will want to find a way to automate updates to these diagrams for a long-term documentation purpose. Okay, so let's talk about UML here. The next. So if I go more drill down, we have 14 types of UML diagrams, and that categorized into two like we have categorized into two parts. So one is structural. Let me, I don't have, not it, but so we have structural diagram and behavior behavioral diagram. Okay, so these are the two categories. So if I go into deep, right, what is structural diagram? So structural diagram provides a static view of a system and emphasizing its components, relationships, and organization. So uh, while a behavioral diagram offers a dynamic view, focusing on the runtime behavior, interactions, and processes within the system. So these are the two categories we have. So under structural diagram, we have class diagrams, object diagram, package diagram, and component diagram, composite diagram, and composite structure diagram, deployment diagram. So these are all comes under structural diagrams. And in the same way, we have behavioral diagram, means dynamic modeling. So under this, we have use case diagram, activity diagram, state machine diagram, sequential diagram, and communication diagram, interaction diagram. timing diagram. So what I'm doing, I'm not going in detail because this is a a very uh, high level overview session. If I go in detail, it will take lot it will take this video more time. So for now, what I'm doing, I'm just giving a brief overview on the UML diagrams. So uh, let me go to the next slide. So this is so yeah. So far we have discussed C4 and we have discussed UML and we have discussed structural diagram. We have discussed on behavioral diagram. Now let's time to discuss on software architectural patterns. Okay. So I've already we've already gone through what is software architectural pattern. Okay. If I go to my first my first sorry, where is the my first slide? Yeah, if you go to my first slide, software architecture is a fundamental organization of system and more defined a structured solution that developers use as a visual guide for building a solution. So we have some patterns defined. So these are the some software architectural patterns. So let me go through all these patterns. So the first one is layered architecture pattern. So if I go to layer architecture pattern is classified into four distinct layers: presentation layer, business layer, persistent layer, and database. So this pattern stands out because each layer play a distinct role within the application and is marked as closed. It means a request must pass through the layer below it to go to the next layer. Okay. So as you know, generally we'll call it as entire also layer pattern. Divides an app into different layers that perform specific functions. So these layers are only able to communicate with the layers that strictly direct below them. Okay, so this one. So like let's say we have a presentation layer. So we are passing once our task is closed here and we're passing to business layer. In the same way, we are passing one layer to another layer. Okay, so it interacts. So the presentation layer can only interact with the business layer, but not the vice versa. Okay, and so let me go to the next pattern. So sorry, I'm not written anything. So this is a client server architecture. Okay, so in the client server architecture, there are multiple nodes or clients connected over a network or internet connection who communicate with the central server. So this is our central server and these are the client, and that's the reason we'll call it as client server architecture. Okay, in a client server architecture, the client, also known as host, sends a request for data or apps, specific services or other resources to a remote computer or a server. So the server then accepts the request, process it and delivers the resource back to the client. Okay, so this type of architecture style is best suited for email services, website, file sharing, apps, or any other type of services that benefits from a call and respond model. Okay, let me go to the another model, another architecture.